Hi, so here's another example regarding the algebraic substitution. See, we have this square root of x once again all over the 1 plus, this time we have x raised to 3/4 dx. Okay, we have here two radicals, so we have the x that is raised to 1/2, and we also have x that is also raised to 3/4 dx. Okay, so how can we simplify this one? So we need to think of some variables that it might lead us to have a power that is not in terms of fraction. Say we have u raised to 1, raised to 2, 3, 4, 5, and so on. Okay, so how can we transform this x 1/2 here and x raised to 3/4 in terms of those variables? Okay, so as you can see here, the difference between the 1/2 and 3/4 is just 1/4, right? So maybe let's try to rewrite this in having an increment of 1/4. Say from 1/4 plus 1/4, we have a 1/2, and then plus 1/4 we have a 3/4, and then 4/4 or 1, right? And if we let this equal to u, then as you can see here, what we've done here is to raise our first term into squared, right? So if we raise this, as we raise the 1/4 squared, we have 2/4 or 1/2, right? And then if we raise this into 3, if we raise our u into 3, we have 3/4, right? And as well as this one, if we raise this into 4, we have 1/4 raised to 4 is 4/4, and we have here x. Okay, so since we have this now, then we can now transform the fractions by letting variable u with a power that is in terms of whole number, so that we can easily apply our basic rules. But we have not done yet, because we need to determine the equivalent value of our dx in terms of u. So we need to integrate this, we need to differentiate this. So we have 4 u cubed du is equal to the derivative of x is dx. Okay, so by having this information, we can now transform our integrand in terms of u. So our x 1/2 is equal to u squared, and then all over, of course, our 1, and then plus our x raised to 3/4 is our u cubed, and then our dx here is equal to 4 u cubed du. Okay, as you can see here, all of our terms are now in terms of u is in terms of whole number. Okay, so we have u squared multiplied by 4 u to the 3 is that we have 2 plus 3, we have u 5, right? And then we have 1 plus u cubed, then our du. Then how can we further simplify this, say what technique? Say let's let once again for another variable, say let z is equal to our denominator. So we have 1 plus u cubed. So the derivative of this is derivative of this is 3u squared du. Okay, so we have the cube, we have u squared, and if we have from here we can now find the value of u cubed, which is equal to z minus 1, right? And here to find the value of our u squared is that we have u squared du na lang. So we have easy all over 3. Okay, because let's erase this one. Let's use our original values, which is 4 u squared. We have u squared multiplied by u cubed du, right? Because as you can see here, we can now find the value of our u cubed and our 1 plus u cubed, and then our u squared du. Okay, so we can now change from the value or the variables from u to z. So let's try once again. So we have 4, let's move out the value of 4, then our u squared du is dz all over 3, right? Let's move the 3 outside, so yeah, dz over 3, and then our u cubed is z minus 1, right? So we have z minus 1 dz, and then our 1 plus u cubed is all over to z. Okay, so from here can now easily use our basic rule integration. So we have z over z dz minus the integral of dz all over z, right? So z over z, and then minus 1 over z, so dz over z. So our final answer is just, we have 3 z over z, or 1 dz is just z, minus the integral of dz over z is ln of z, then plus c. Okay, but we need to bring back the value of our z, which is, what's the value of our z? Is 1 plus u cubed, 1 plus nga ba? Plus u cubed, and then that is this one, and then minus ln of 1 plus u cubed, okay, then plus c. But we also need to bring back the value of our u, which is, the value of our u is u cubed is x raised to 3/4. So we have x raised to 3/4. So 1 plus x raised to 3/4 minus ln plus 1 plus x raised to 3/4, and then our plus c. So this is now our final answer. Okay, so let's do a quick review. First, we have a problem which is in terms of square root of x all over 1 plus x raised to 3 halves, and then we rewrite this in terms of fractions. So x raised to 1 halves, and we have 1 plus x raised to 3 fourth. And then we notice that the increment of this is by 1/4 and 1/4. So we need to think of some variable that if we let that this variable raised to some number that might produce to some variable in terms of whole number, or in terms of not in fraction. So we say that if we let our u equal to 1/4, and then if we square this, our x became x raised to 1 half, and then if we raise the u into 3, then our x became x raised to 3 fourth, and if we raise our u into 4, and then our x became 4/4 or 1. Okay, and from that we use the value of our dc, we use the value of our u to simplify our integrand, and before that we need of course to determine the derivative of the u, so that we can now change the value of dx in terms of du also. Okay, so after that we transform our integrand in terms of u. So from x we transform our integrand in terms of u, and then from here we notice that if we again use some substitution, so we chose the denominator as c, which is equal to 1 plus u cubed, and then we get the derivative of that, and we do some algebra here for us to transform all our u into from u to z, variable z. Then from here we can now easily see that it is now integrable by doing some minor algebra, z minus 1 all over z, or z over z minus 1 over z. Then from that we apply the integral, and then we come up with this one, but we need to bring back the value of our z, which is u cubed, and our u cubed is also equal to x 3/4, and that is now our final answer.